Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Safiya Nadirah binti Muhammad from RCS 143GE. Today I'm going to show about converse, contrapositive and inverse. Let's say we have two propositions, proposition P and proposition Q. So P is the hypothesis and Q is the conclusion. So here we have P implies Q. So from this statement, how do we find converse, contrapositive and inverse? Let's see. Firstly, converse. To form converse, we have to interchange the hypothesis and the conclusion. So for the converse for P implies Q is Q implies P. Next, contrapositive. So for contrapositive, we have to interchange the hypothesis and the conclusion of the inverse statement. So the contrapositive for P implies Q is negation Q implies negation P. Lastly, inverse. To form inverse, we have to put negation in both hypothesis and the conclusion. So for the inverse for P implies Q is negation P implies negation Q. Let's see example 1. Given an if-then statement, if P then Q. So P, Aiman is rich. Q, Aiman owns a car. P is the hypothesis, Q is the conclusion. So P implies Q. If Aiman is rich, then he owns a car. So the converse for this statement is Q implies P. If Aiman owns a car, then he is rich. Next, contrapositive. Negation Q implies negation P. If Aiman does not own a car, then he is not rich. Lastly, inverse. Negation P implies negation Q. If Aiman is not rich, then he does not own a car. Let's move to example 2. The statement given is, if it is raining, then the pool is closed and the swimming class is cancelled. There are three propositions here, P, Q and R. P, it is raining. Q, the pool is closed. R, the swimming class is cancelled. So P implies Q and R. The converse for this statement is Q and R implies P. Converse, if the pool is closed and the swimming class is cancelled, then it is raining. Contrapositive, if the pool is not closed or the swimming class is not cancelled, then it is not raining. Inverse, if it is not raining, then the pool is not closed or the swimming class is not cancelled. Lastly, example 3. If Lily lives in Ketari, then she lives in Pahang. P, Lily lives in Ketari. Q, Lily lives in Pahang. P is the hypothesis and Q is the conclusion. P implies Q. If Lily lives in Ketari, then she lives in Pahang. The converse for this statement is Q implies P. If Lily lives in Pahang, then she lives in Ketari. For contrapositive, negation Q implies negation P. If Lily does not live in Pahang, then she does not live in Ketari. And lastly, inverse. Negation P implies negation Q. If Lily does not live in Ketari, then she does not live in Pahang. That's all for converse, contrapositive and inverse.
Assalamualaikum and hi, my name is Nur Hidayah binti Muhammad Azam Shah and I'm going to present about chapter 2, Laws of Logic. Let's begin our lesson. There are 12 laws altogether. Number 1, double negation. For example, double negation P equals to P. Number 2, De Morgan's law, when negation means with bracket. Number 3, commutative law, when two different propositions change positions. Number 4, associative law. It happens when the sign outside the bracket and inside the bracket is the same. Number 5, distributive law. We apply distributive law when the sign outside the bracket and inside the bracket is different. Number 6, idempotent law, when P or P equals to P, P and P equals to P. Number Number 7, inverse law. When P or negation P equals to tautology, P and negation P equals to contradiction. Number 8, identity law. When P or contradiction equals to P, P and tautology equals to P. Number 9, domination law. When P and contradiction equals to contradiction and P or tautology equals to tautology. Number 10, definition of implication. When P implies Q equals to negation P or Q. Number 11, definition of biconditional. When P equally implies Q equals to P or Q and Q implies P. Number 12, absorption law. We apply absorption law when the proposition outside the bracket and inside the bracket is the same, and also the sign outside the bracket and inside the bracket is different, so it equals with P. Examples of laws of logic. Example 1. Show that the following expression is a tautology by using the laws of logic. So how to solve this question? First thing first, we can see the implied sign in here. So we know that we have to use the definition of implication law. And then we see that P is here and also here, plus the sign is different outside and inside the bracket. That means we have to use absorption law. When C double negation here, we know that we have to use De Morgan's law. The sign here, and also here is the same, so we can use associative law. And then it's better if we can change the position between these two so that we can classify P and P together by using commutative law. Because the sign is the same, we can use associative law, and then P or P equals to P by using idempotent law. Negation R or R equals to tautology by using inverse law. P or tautology is tautology by using domination law. So it is shown. Example 2. How to solve this question? Firstly, we see that negation here, so we know that we can use De Morgan's law. And then double negation here, we can use De Morgan's law too. Then because it's the different sign right here and also here, we know that we can use distributive law. Then we see that negation P and P is together, that means contradiction by using inverse law, and then contradiction for any proposition equals to that proposition by using identity law. So it's shown. And last but not least, example 3. First thing first, we see the implied sign in here, so we know that we can use definition of implication law. And then we see negation sign in here, that means we use De Morgan's law. Next, we see the sign here is the same right here and also here. We know that we have to use associative law. And then we see that we have to change the position between these two by using commutative law. Because it's the same sign here and also here and also here, we use associative law again. Then when negation P or P and then negation Q or Q equals with tautology or tautology by using inverse law, so we get tautology by using domination law. So that's it, it is shown.
That's it for this subtopic. Thank you for listening. The next subtopic will be explained by other presenter. Thank you.
Okay, hi, my name is Nurul Suhaila. Now let's move on to next subtopic, which is argument. What is argument? Is it a fight? No, absolutely not. Argument is a list of given statements called premises and followed by the final statement called conclusion. The premises from the hypothesis of the argument and the conclusion can be expressed as this. An argument is said to be valid if whenever each premises is true, then the conclusion Q is also true. Besides that, we can check if an argument is valid or not through truth table, laws of logic, or rule of inference. Rules of inference is the best way to check the validity of an argument because it's more practical. Now let's do some example. Okay, now let's continue to example 2. Prove the argument below is valid by using rules of inference. So this is the premises and the conclusion is negation P. How we can get the negation P? So first of all, we need to list all of the premises one by one. negation S and T for negation T or U. 5 negation U. Okay, we move to next premise. So we can see that from 1 and 2 we can use laws of syllogism. We can get P implies S. How can I get the answer? We cross the R. So now next premise is from 4 and 5. As we can see, we can use rule of disjunction syllogism. And we will get negation T. How I get negation T? We cross the U and negation U, then we get negation T. Next premises is from 3 and 7. We also use rules of disjunction syllogism. And 3 and 7, then we will get negation S. And next, from 6 and 8, we can use modus tollens. 6 and 8. As we can see, we get negation P. So we can see that negation P at here and this is same. So argument is valid. Thank you. That's all. Thank you.
Hi and Assalamualaikum. My name is Nur Aisyah Amalin binti Nur Asman and I am from RCS 143 3E. What is a mathematical induction? Mathematical induction is used when P has the form for every integer n is bigger and equals to 1. Something happens where something happens is a statement that depends on the integer n. There are 3 steps in mathematical induction. The first one is by verifying that P1 is true. Replace the n everywhere in Pn by 1. And the second is assume that Pn is true. And the last one is prove that Pn plus 1 is true. Start by writing Pn plus 1 and then rewrite Pn plus 1 in terms of Pn. Example 1. Prove that 1/3 plus 2/3 plus 3/3 plus ... plus n/3 is equals to 1/4 n square 1 n plus 1 square. As for step 1, we need to verify that P1 is true. As it's shown here, 1 is equals to 1, which is P1 is true. And for the second step, we just need to assume that Pn is true, like here. And for the third step, we need to show that Pn plus 1 is true. We use the left hand side and right hand side method. And in the end, when we calculate the method, we will get the same, which is left hand side is equal to right hand side, which is proven. For example 2, we need to prove a mathematical induction that all n is bigger and equals to 1. This is the equation 1 plus 4 plus 7 plus ... plus 3n minus 2 is equals to n 3n minus 1 over 2. After we get the equation, we need to change into this type of form. As for step 1, we need to verify that P1 is true. As you can see here, 1 is equals to 1, which is P1 is true. And for the second step, we need to assume that Pn is true. We just need to assume that this one is true. As for step 3, we need to show that Pn plus 1 is true. Use the method left hand side and right hand side. For the left hand side, we use Pn plus 1, and for right hand side, we use Pn plus 1. In the end, we can see that left hand side and right hand side is the same answer, which is proven.
Hi, in this video I would like to explain about chapter 3 subtopic, which is the forward and backward method. So basically, the forward and backward method is to prove if A then B is true. We will assume that statement A is true and use it to show that statement B is true. Okay, what is statement A and statement B? Statement A is the hypothesis of this question and statement B is the conclusion of this question. There are two processes for this method, which is forward and backward method. But firstly, we need to go through the backward process to figure out how to get the statement B is true. Only after that, we will go through the forward process by begins with the statement A, which we assume to be true, and derive it until we get the last statement, which sits as the last statement in statement B. Lastly, we need to prove the process by arrange the forward process step in ascending order and backward process step in descending order. Only after that, we will conclude in condensed proof process. Okay, here is an example question for this method. If n is even and m is odd, then 2m squared plus n squared is even. Okay, first thing first, we need to find the hypothesis and the conclusion for this question. So the hypothesis is n is even and m is odd, and for the conclusion is 2m squared plus n squared is even. Firstly, we will write out the B statement or the conclusion, which is 2m squared plus n squared is even. Okay, for the next step, we will show that this statement is true. So how to show it? Okay, as you can remember, any integer that multiply with 2 will get an even number. So for the next step, we will do 2m squared plus n squared equal to 2k, which is k is an element of an integer. Okay, the backward process for this question only have one step to show that the statement B is true. After that, we will do the forward process. Same as backward process, we will write out the A statement, which is the hypothesis. So the A statement is n is even and m is odd. For the next step, we need to show that n is even and m is odd. As previously, we knew that any integer that multiply with 2 will get an even number. So to get an odd number, we will plus 1 with the multiplication of 2 with an integer. So we will get n equal to 2a and m equal to 2b plus 1. Which is a and b is an element of an integer. So, for the next step, we will substitute n and m into the equation. So it will be 2 in bracket 2b plus 1 square plus in bracket 2a square. After substitution, we will expand the equation until we get 8b square plus 4a square plus 8b plus 2. After that, we will factorize the equation to get 2 in bracket 4b square plus 2a square plus 4b plus 1. Okay, by letting this equation into p, we will get 2m square plus n square equal to p, which p is an element of an integer for the last step. Okay, now as you can see, we have proved that the last statement of forward process has link with the last statement of the backward process. Therefore, B is equal to 2m squared plus n squared is even. All these are the step arrangement for forward and backward process. Lastly, we need to do condensed proof process, which is the conclusion of all steps from forward to backward process. So the condensed proof for this question is n is even can be written as 2a and m is odd can be written as 2b plus 1. By substitute n and m, the equation will be 2 in bracket 2b plus 1 square plus in bracket 2a square. After performing some algebraic expression, then we let 4b squared plus 2a squared plus 4b plus 1 into b. Hence, we obtain 2m squared plus n squared equal to b. Then 2m squared plus n squared is even. Okay, that's all from me. Thank you.